Now we are going to see theorem 6.2. This theorem is also called as converse of basic proportionality theorem. This theorem states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So that means, see, there's a triangle like this, triangle ABC. Let me draw the triangle like this. So let me draw a line like this. This line, let this be D. This D is cutting this AB into AD and DB. This point D is cutting here, and this point E also is cutting this AC in this part. Now, so we have so many parts. We have AD, DB, AE and EC. This theorem is saying that if AD over DB is equal to AE over EC, if this is true, if both the fraction ratios same, if both are same, then what happens? This DE will automatically become parallel to BC. This DE will become parallel to BC. If this ratio is same, then only DE will become parallel to BC. Then DE will become parallel to BC. This is the important part. DE will become parallel. If you want to check two lines are parallel, then it is enough to prove that this ratio is same. Now let us take a small example to see how can we use this theorem. So here's a figure. Triangle ABC is there, and AD is 12 cm, DB is 8, AE is 13.5 and EC is 9. We have to check if DE is parallel to BC. We have to check. How can we check if DE is parallel to BC? First you have to take the ratio, this over this and this over this. If both the ratios are equal, then we can say D is parallel to BC because of the theorem you just learned now. So let us take the ratio AD over DB. AD over DB is equal to how much? 12 by 8, which is equal to 3 by 2. Now let us take AE over EC. AE over EC is how much? 13.5 over EC is 9. If you shift the point like this, it will become 135 over 90. This is also equal to, both can be divided by 45. So if you divide this by 45, you will get 2. And if you divide this by 45, you will get 3. So 3 by 2. See, the ratio is same. Here also 3 by 2, here also 3 by 2. So AD over DB is now equal to AE over EC. So therefore, we can say D is parallel to BC because of this theorem we just learned now. This is a theorem, so it is having a proof. This proof is to know why this theorem is working every time. So now we will do the proof. To start the proof, we have to write the given information first. What is given? We have triangle ABC, DE. This line is intersecting AB and AC. And the main information given is AD by DB is equal to AE by EC. From this information, we have to prove that D is parallel to BC. So to prove DE is parallel to BC, first we will assume one thing. We will assume DE is not parallel to BC. If you want more content like this, please click the subscribe button. So DE we are assuming not parallel to BC. First we will assume, the thing we have to prove is DE parallel to BC, but we are assuming that if D is not parallel to BC, then what will happen after so many arguments we will see now. If D is not parallel to BC, if you are assuming, then there would be some other line which would be parallel to BC. Let that be DE dash. Okay, let's draw another line and see what happens. I will draw this DE dash, this line, DE dash. Actually, DE dash is not parallel to BC, but to prove that we are just assuming. So we have drawn a line DE dash parallel to BC. So if DE dash is parallel to BC, then we know that in basic proportionality theorem, this AD by DB will be equal to AE dash by E dash C. AD by DB is equal to the reason is basic proportionality theorem. We learnt in the previous theorem. It was given that AD by DB is equal to AE by EC. So instead of AD by DB, I will write AE by EC because it was given. Instead of this, I will put AE by EC equal to, after this RHS, let that be as it is, AE dash by E dash C. Reason is given. It was given that AD by DB is equal to AE by EC. Now the next magic I'm going to do is I'm going to add 1 on both the sides. Let's see what happens. Add 1 on both sides. So AE by plus 1 is equal to AE dash by E dash C plus 1. I will cross multiply EC into 1. I will cross multiply this because we have a fraction here. AE plus EC into 1 is EC. Denominator will be as it is, EC is equal to AE dash plus E dash C into 1 is E dash C divided by denominator is E dash C. E dash C. Now we have a numerator AE plus EC. What is AE plus EC? This is AE, this is EC. AE plus EC is full side AC. So this implies AC. AC will come in the numerator. Denominator, let that be as it is. EC is equal to AE dash plus E dash C. AE dash plus E dash C. That's also this complete line AC. AC by E dash C. Now we have AC in the numerator on both the sides, so we can cancel that. Now we will get 1 by EC is equal to 1 by E dash C. If you cross multiply this, you will get EC is equal to E dash C. What does that mean? Both line segments are actually equal. But see, EC is here, this is EC, and this is E dash C. E dash C is bigger and EC is just small. But now we just prove that both are equal. Both are same line segment. How can this happen? It's because we have just assumed a wrong thing. We have done a wrong assumption that DE dash is parallel to BC. But that is false statement. We just proved that this E and E dash will coincide. E and E dash must coincide. So we have done the assumption that DE dash is parallel to BC. Now we have just proved that E and E dash are actually the same point. This line will come like this and will become parallel. So instead of E dash, put E. DE is parallel to BC. See, that's what we had to prove, and finally we have proved it. Hence proved. So whenever the ratio is same, AD by DB is equal to AE by EC, then DE will become parallel to BC.